Welcome to your Get That Nugget for GCSE Maths. Today we will be concentrating on giving you a framework to answer grade 3 dividing in a ratio questions. So questions all about being given a ratio and dividing a quantity or a value using that ratio. Please note, this session is to complement your lessons with your teachers. It is not to replace them in any way. Okay, so without further ado, let's have a little look at some examples so we can ensure we are confident when it comes to sharing in a ratio. Now, I'm going to give you a couple of methods. The first method we're going to work through often works in most scenarios, but there's a few times when if the numbers are large in the ratio, it can be a little bit time consuming, but we'll explore that when we get to that final example. So, Jacob and Jess are going to share £200 in the ratio 2:3. Calculate how much each of them receives. Fairly straightforward, hopefully, when we come to look at this. Now, I've chosen the first one as an example because I've chosen Jacob and Jess. They both got a J. So I don't want to get confused about which one's the J. So how we're going to do this question, and we're going to introduce, I don't know if it might not be new for you, but it's called the box method. So what we've got, I'm going to write Jacob's whole name out. Normally we could shorten it, but just for this instance, having chosen the same letter, it might make it a bit confusing. So Jacob and Jess, they share £200 in the ratio 2:3. Now, the first number always corresponds to the first person in the question. And what I've got is I've got 2 boxes for Jacob. The reason I've got 2 boxes is because in this ratio, he's represented by the 2, which means Jess is represented by the 3. So we call this method the box method. Now, how much money did they share? Well, they shared £200. And if we look, it's quite nice visually. We can see that they've shared it amongst these 1, 2, 3, 4, 5 boxes all together. And what's nice about ratios, each of those boxes, each of those values has to be the same. So in effect, they've shared £200 amongst 5 parts, 5 pieces, 5 boxes. So what I'm going to do first is work out what each individual part is going to be worth. So when I do 200 divided by 5, how many 5s in 20? Well, there's 4. How many 5s in 200? And that's going to be £40. That's my first step, because what that tells me is each of those boxes is worth 40. Now, you don't need to write this in, but it just helps visualize the question, because I can see that they clearly add up to 200. So it must work, which means that Jacob has got 2 lots of 40, which means Jacob received £80. And Jess has got 3 lots of 40, which means Jess clearly received 120. How do I know it's definitely right? Well, those 2 values add up to 200. So that's called the box method. It helps you visualize what it is you're doing with that quantity or that amount. And there's your answer. Jacob 80, Jess 120. Lovely. How can they become a little bit tricky? Well, what about if we've got 3 parts to a ratio? So here I've got Ravi, Bill and Sarah, and they've got 48 sweets. They decide to divide them in the ratio 2:5:1. How many sweets do they each get? So fairly straightforward. And guess what? We're going to use the same method as before, but this time I've got different letters for each person, so I can use the letters rather than having to write out their names. So Ravi, Bill, and Sarah. And again, really important we correspond the right number in that ratio to the right person. So Ravi's the first number, the first person. So Ravi has 2 boxes. Bill is the second number, so Bill has 5 boxes. If you notice, I've gone 1 short. It's not a problem because I just add it on the end. And then Sarah has got 1 box. Okay, this time they're not sharing money, they're sharing sweets, but the process is exactly the same. I've got 48 sweets. Okay, and I need to divide it by the number of parts I've got. So 1, 2, 3, 4, 5, 6, 7, 8. Are we happy? It's 8. Yep. So if I divide it by 8, how many 8s in 48? Quite give me 8 times table. That is going to be 6, which means every one of those boxes is worth 6. So if you want to write the 6 in, you can. So I'm just going to do it so it's nice and clear and you can see where the values have come from. And then I can clearly see that Ravi has got 2 lots of 6, which means Ravi gets 12 sweets. I know that Bill's got 5 lots of 6, which means he's got 30. And then Sarah on the end has just got 6. And it's always worth a quick sense check. 12 plus 30 is 42. 42 plus 6, guess what? Gives me 48. So There's no missing sweets. I'm not got some values wrong, so I'm happy. Process, job done. So the key, boxes in order, divide by the total number of the boxes you have, tells you what goes in each box. Perfect. Okay, example 3. What have we got for this question? So, bit more of an application question. So the angles in a triangle are in the ratio 1 to 2 to 3. Find the size of each angle and state the type of triangle. So not listed with names, which is fine. I can just call them A, B, and C if I wanted to. That's absolutely fine. A, B, and C. And I can see that A, I'm going to give it 1, which is the first number. B, I'm going to give it 2. And then C, I'm going to give it 3. What's confusing about this question is there is no number. There's no value to share, which is what will confuse people because they're like, well, I don't know what it is I'm meant to do. What numbers go in there? What do I divide by? The key is this, the angles in a triangle. So you have to have a bit of prior knowledge for this question in terms of, do I know how many degrees there are in a triangle? Well, hopefully you know that there are 180 degrees in a triangle. If you didn't know that, it's very difficult to start this question. It's one of those bit of knowledge that you'd need to know. So I know that there should be 180 degrees. So what I'm now going to do is divide that quantity by the number of boxes. 1, 2, 3, 4, 5, 6. So if I divide it by 6, I can see that 180 divided by 6, well, 18 divided by 6 is 3. So that is going to be 30, which means each box is worth 30. So 30 is going in each, which means angle A is 30 degrees because the question wants me to find the size of each angle. Angle B is 60 degrees. And then angle C is 3 lots of 30, which is 90 degrees. So find the size of each angle, 30, 60, 90, and state the type of triangle. Well, I can see it's got a 90-degree angle in it. So if I wanted to do a little sketch of this one, for example, this is just me going an extra step. I've got a 90-degree angle here. I've got a smaller angle of 30 here. And then this angle would be 60. I don't need to draw this one, but just so it's nice and clear for you. I can see that actually I've got a 90-degree angle in my triangle, which means it has to be a right-angled triangle. So that would be your extra little mark of, again, using your knowledge of what type of triangles have I got. And I know that because one of the angles in the question has to be 90. So there's a little sort of extension part to that one. Right, we're going to look at one more example where you might not like to use my method, but it's in terms of the box method, sorry, not my method, but the box method. So here I want to share 240 in the ratio 3 to 17. Now I could draw my boxes, 3 boxes here, and I'll have 17 boxes. But in this instance, it might be a bit time consuming. So the other way that you can do these questions, if you're not confident with the box method or you don't want to write all the boxes out, is you can see that I've got 3 to 17. So if I were to draw the boxes, I would have a total number of parts or boxes would be those 3 boxes plus the 17. So the total number of parts would be 3 plus 17, which would mean I would have drawn 20 boxes. That's effectively what I would be doing. Draw the first 3, draw the next 17, and then what I would do is I would have to divide my amount by the number of boxes. So what I would do is I would do 240 and I would divide it by 20. How many 20s are there in 240? Well, that would be 12. So I know that each part is worth 12, okay? So each part's worth 12. So 3 parts are going to be 3 lots of 12, which means the first one's going to be 36. And then the 17 parts, well, I know that each part is worth 12. So again, I would times it by 12. 17 times 12, well, I think that's going to be 204. So that is another way of doing that question in terms of if you know the number of parts, which is 3 to 17. So if I do 3 plus 17, that tells me there are 20 parts, which is the same as 20 boxes. So if I divide my amount or the value I have by the number of those parts, then each part or every box is worth 12. So because the first part is 3 parts times by 12 means that that's worth 36. And then the next number in the ratio is 17, which represents 17 parts. So 17 parts times 12 tells me that that part or that aspect of the ratio has to be worth 204. If we do a quick check, we can see that that adds up to 240. So if you have a high number in that ratio, you might not want to draw the boxes out. So it's just being aware of, okay, it's just a visual representation of the number of parts. So that's effectively dividing a ratio. What I'll do, as always, I'll pop some questions for you to take away and have a little look at. Here we go. So there's a pretty standard sharing a ratio question, one involving shape, and then a little bit more of an application, thinking about total costs, etc. So applying a few more extra marks to what might turn up in the exam. Have a go at those.